In this video, we're going to get started creating our injection molded plastic housing for our electronics. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to go ahead and begin to tackle our actual plastic housing design. In the last video, we did some concept work and we played around with some shapes, and I talked about different ways in which we could use those to build our final design, but essentially we wanted to look at how the concept phase could be helpful, allowing us to make changes and move the shape around and play around with the design until we get to a shape we're happy. But as I mentioned, we're not going to be using any of that concept work. So what I'm going to do is I'm going to rename the different sketches for making sure that we understand that these were concept. I'm going to do concept 1, 2, and 3. And then I'm going to make sure that I hide the bodies and that I hide those sketches. The one body that's left behind is that PCB, which we can keep if we want, but it can also be hidden. It is a good idea for us to rename it, so PCB. And then I'm going to call this concept 1 and concept 2, just so I remember that those bodies are there and they're part of the concept. So now that we've sort of played around with the concept phase and different ways that we could sort of realize a shape that we want, we're going to go ahead and we're going to make a shape and we're going to talk about the actual plastic features that are needed. Now, when we look at this thing from the top, we have a PCB shape that we already know that we're going to use. You can see that we ended up drawing it over here and we moved everything so that our origin or coordinate system would be at the center. And we have that PCB board. So we can hide the actual board so that way it's a little bit cleaner. And note that we have the microcontroller, it's the Adafruit QT Pi, and that's in here and we're going to need that information as well. But for right now, we can also hide that. Because what we're going to do is we're going to focus on the base of our design. We already talked a little bit about the Hammond box that we can get and the fact that it had the lid and the screws went down into this big boss here. And what we could do is we could try to replicate that or we could flip it around. It really just depends on how you want the board and how you want the pieces to be used in the real world. We know where connectors are. We know we're going to need an opening on these two sides. We know that the QT Pi has a USB-C and this quick connector. And there's also this little reset button. So it might be helpful for us to have access to either put a screwdriver in from the side or a little hole that we can press down from the top to reset the board to restart it. So those are design considerations that we need to be mindful of. And again, this side of the board has the larger components on it. So we need to kind of be mindful of that. And the other components are all relatively small. They're pretty minimal. There's some resistors and things on the bottom, but everything is pretty minimal except for this microcontroller and these transistors that we need to worry about. So when we look at this, we're going to get started. Again, first I'm going to hide that and I'm going to focus on this clean representation of the board. This is going to be the starting point for my housing. So I want to start a new sketch and I'm going to create the sketch on the face of this. I'm going to use this as the basis for my design. Remember that I have the origin here, so I can use a center point rectangle and I can bring this out, make sure that I encompass the entire board. I don't know the dimensions I need just yet, but what I want to do is I want to use this and I want to offset from the board a certain amount. So I'm going to use my dimension tool and I'm just going to pick an amount that looks okay. Remember, we can make it as big or as little as we want, but making sure that we have dimensions to drive it is going to be the important factor. So I'm going to say 3 millimeters, and we can also actually create a user parameter or a variable at this time if we wish. So for example, if this was board offset, so oftentimes what happens if somebody starts to type something, they want to go and simply do board offset. And if you do the name, remember, we can't have any spaces, but we can do an underscore or use capitalization to break words up. If you do the name and equals 3, then what we've done is we've created that parameter. If we go into modify, change parameters, you can see in our favorites, It's located in the sketch. It's not at the top level in the user parameters, but the name is board offset, and now we can use that over and over again. So in here, D on the keyboard to dimension, what we could do is we could click on this value and hit enter, and it'll be linked. And because we're using a center point rectangle, that's all we need. We just need those two values. We could also simply type in board offset. It would work the same as it does with user parameters. So now that we have this base sketch, here is the time where we need to start making some important design decisions. Obviously, we're not going to have square corners. We're going to have rounded corners. But do we place them as fillets in the sketch, or do we place them as features in the timeline? And there are reasons why we would want to do one over the other. But if we try to use a fillet in here, keeping in mind that our center point rectangle is based on things like parallel relationships and equal distances that are offset from this board, notice that this is going to affect those construction lines. So if I say okay, and I add a 6.5mm fillet, you can see that this is fully defined, but now I get this constraints and or dimensions were removed. Even though it looks like it's still fully defined, it added tangency here. We lost the coincident relationship with that horizontal line, or that construction line, I should say. So if we go around and we do this in a couple different places, what ends up happening is we're breaking the relationship between these edges. So I want to be very careful when I have a fully defined sketch and I begin doing things like adding fillets, because it does cause problems, especially when it's a rectangle and not a square. It's going to be much harder for us to fully define that or figure out where those issues are. So what I like to do in most cases is going to be to use a fillet after the fact as a feature using the fillet tool, rather than to do it at the sketch level. Now, obviously, there are exceptions to every rule. So in some cases, you might decide that doing it at the sketch level is better. But for this example, doing it at the feature level is going to be a better option because it helps us keep a simple, fully defined sketch, and we don't have to worry about those fillets if we decide to change them later. So it's going to be easier for us to change the fillet later as a feature in the timeline rather than at the sketch level. So now that we've created this sort of offset base, this is based off the bottom of that PCB shape. That's obviously not where the bottom of the housing is going to be because we need bosses that we can use to attach the PCB to. And for that, we need to really look at our actual PCB to see things like components that are on the bottom and how much space we need. So what we have to do at this point is we need to create a solid somewhere below the part, and we need to figure out where that's going to be. So what I want to do is I also want to, in this sketch, figure out where those screw locations are going to be, and I'm going to just add them to the sketch even if I don't use them at this time. So remember that our screw has a min and a max diameter value. So I'm going to start typing min, and even though it starts with hole, you can see that min comes up. So I'm going to use that hole min value, then I'm going to add another circle to this, and I'm going to click, and then use D for dimension. And what I want to do here is I'm going to do the IN for in wall thickness. So this in wall thickness parameter is going to determine how thick that boss needs to be. And we can see that the screw size we're going to use and the boss or the plastic wall thickness is going to be just fine in this case. I'm going to repeat the process over here, C for circle. And if you happen to miss the location or don't place the dimension, you can just drag this around until you find the center location of that arc. Or what we can do is we can actually use the reference. Remember that this is the board itself, its shape is in our sketch because we clicked on it to start. So what we can do is we can pick these and we can make them concentric. That'll automatically snap those center points. And then we can continue to use dimensions, or we can use equal. Now, the important consideration here is to make sure that we're not adding additional dimensions or constraints or things that make it harder for us to control. If we decided later on that the wall thickness or the diameter of this hole or something had to change, then we would want it easily updatable. We want it to change everything. So we could go into modify change parameters, and we could change the hole min value, and it would update the sketch. So let's take a look at this. I'm going to go ahead and just pull this up a little bit. If I say that the hole min value instead of 1.85 actually needs to be 2, I'm going to hit enter. It updates both of those. Let's make it a bit more drastic so it's easier to see. You can see both updated. The wall thickness is still consistent because it's based on this in-wall thickness. I'm going to reset this to 1.85, but just note that those changes, linking these together, either through our parameters or through the equal constraint, means that it's easy for us to update. And making sure that we define the wall thickness based on our parameter, rather than coming in and just putting a dimension in there like 2 millimeters, it makes it easier for us to update everything downstream. And these are going to be key to making sure that your design is flexible enough. So now we have the base of our design. We have this whole location and this whole location. The only thing we don't have is going to be the location for the holes in the PCB, how we're going to hold the PCB down. So we can use a couple tricks here. We can either put screw bosses to hold it down, or we can come back later and we can create some snap fit pieces that hold the PCB down. And these can be snap fits on the side of the board if we have the room, or they can go through the screw holes. Putting screw holes or drill holes in PCBs sometimes can increase the cost. So keeping in mind that we have other options, for example, using snap latches on the sides of the board can be a helpful solution, especially when we're using low production volumes or prototyping. So I think this is going to be the stop of this sketch. I'm going to go ahead and rename it right away. I'm going to call this base sketch, and I'm just going to put a 1 after it in case I end up having more sketches that I need. This is also a good time for us to save to make sure that we have a version that captures this. So from here, now that we have the base shape, the next thing that I'm going to do is I'm going to bring back the PCB so we can see the components. And I'm going to create a solid base. I want to have a starting point that is a nice flat base. We might change it later, I'm not really sure. But if we're going to consider something like 3D printing, then having a flat base helps us with the 3D printing. But if we're going to consider injection molding, then the flat base really doesn't buy as much. But again, it's a starting point. I'm not going to worry about wall thickness right now. What we're going to worry about is the location of this. So we're going to create an extrude. I am going to select all the profiles on the bottom. So even the holes, I want to fill in everything. These holes, because we use the bottom of that PCB shape as the sketch, it's going to have all those profiles in it. And then I want to begin by offsetting this. So instead of using profile plane, I want to offset it. And let's go ahead and add 2 millimeters and see where that puts us. You can see we're not quite clearing some of these components, so I'm going to increase that to 3 millimeters. And everything on the bottom of the board is relatively small, but we do have some of these larger capacitors and there's some chip resistors on the bottom that we need to be mindful of. Also, if you are prototyping these boards, if you're making something on your own, the ideal situation for leads of components to go through and the amount of solder that gets built up on them, those aren't captured in a PCB design like this. These are all ideal situations. Now, if you're dealing with surface mount stuff, you're pretty sure where that's going to be. But when you're dealing with through-hole stuff, I can actually push these down quite a bit more, force the leads through, solder them, and cut them off, which means that these components will be lower, but the solder and the leads on the bottom might stick out farther. So we need to just be mindful of those things. So you'll notice that the thickness right now is very small, 0.053. And again, I'm not concerned with wall thickness here. So what I'm going to do is I'm actually going to make it 5 millimeters. And the reason I'm going to do that is because I might want to come back and just change the shape of this. Later on, we're going to build a solid volume. We're going to shell it or thicken it if it's a surface. And then we can worry about the rest. But right now, really what I'm focused on is making the location of that inside face where it needs to be. And that's this one here. So I'm going to say, okay, and now this is the basis for my design. Now, at this point, note, I didn't add any draft. I didn't put the draft amount, the 2 degrees that we incorporated. I certainly could, but one of the reasons I didn't is, for one, I don't know if I'm actually going to use this body or not. And two, I don't know if the shape of this body is going to change. It might change, it might not, it might just stay flat. It really just depends on the design intent. But I'm not quite ready to add draft, even though I could in that extrude. Once again, let's do a quick save. It's good to save often, and then we can add a little bit more detail. Now we have our next design decision. So we built this solid body that's sort of the basis of everything that we're going to do. But are we going to build the housing out of solids, or are we going to build it out of surfaces? So there's really not a right or a wrong answer here. Now you can choose any option that you're comfortable with. Surfaces give you a little bit more flexibility when you're making complex shapes because you can work one face at a time. Whereas solids, you have to work more broadly. You kind of have to build the entire thing. And generally, what you do is you build a solid and you might hack away at it, or you might build the complex shapes with things like lofts and different curves. So, because we really haven't covered much in terms of surfacing, I think I want to progress with this design using surfacing tools. So now that we have the basis for our design, this face, what I want to do is I want to create a surface that we can use as the base. Now, keep in mind when we're working on designs, we have to consider the end use. Now, in this case, the end use of this thing was the intention was a headlight controller on one of my motorcycles. So it was using 12-volt input from the bike, which is why we have a voltage regulator here. And then it was using 12-volt input based on high, low, or off switches, which is why we have BJTs. And then it was using the pulsing of one of those to control the LED headlight. So we've got two for the inputs, and then we have one that was controlling the output. So these all three of them are not the same. Two of them are the same, and one of them is different. So this functionality means that it was going to be zip tied on a motorcycle behind a headlight or bolted somewhere, which means that the flat face doesn't really buy us much. It's not really important that it's flat unless we had a very specific location for it. Now, the flat face might help when we're prototyping, but generally you're not going to prototype with something inside of a final housing. When you make things like housings for Arduinos, they're big and they're flat, and generally they're meant to sit on tables for in project boxes. This having a specific application, we don't really need to worry so much about it being flat. So what I'm going to do is I'm going to create a sketch. This time I'm going to create a sketch on this plane. Now I already know what the base shape is. I know the size of it. I know that this is 3 millimeters offset from the board. I know where the hole locations are based on that sketch. So this helps me define the inner constraint of that face. So I know that this point right here is going to be the inner constraint, or the place where I need to put things like my bosses to hold the board and to screw it down or snap latch it. But it doesn't have to be flat. The board is flat, which means any boss or anything that comes up to it should be flat, but the actual design doesn't have to be flat. That can be taken care of by the way in which we manufacture it. So what I'm going to do is use Create. I'm going to go to Project, Include, and Project. And I'm just going to take these corner points, these references off the solid face, and I'm going to say OK. Then I'm going to use my Create Arc tool, a 3-point arc. I'm going to go between these two. Then I'm going to just draw a very gentle arc. Now, remember when we're talking about injection molded plastics, we want to avoid flat faces when we can, because when they start to cool, they'll end up pulling in on themselves unless we add a bunch of different ribs and things on the inside to help with the structure or the strength. So a lot of times when you see things that are perfectly flat or close to flat, you might see sort of a web pattern on the inside, even if it's very minimal, a grid or some sort of web pattern on the inside. And that's generally to give the surface or the structure some rigidity, some strength, so that it doesn't tend to buckle in on itself. So we want to have those gentle shapes, the very mild arcs and those gentle shapes. And anything that you look at, from your cell phone to your TV remote to any plastic part, you'll often notice that at least in one direction, they might have very mild curvature. It's not always the case, but if you have a big flat face, it's going to cause problems. Because we are designing for the final housing, now we do want to make sure that we are fully defining everything. So I'm going to give this a very gentle arc. So I'm going to say 650 millimeters. That's really large, which puts the center point way out in space. That's kind of unfortunate when you're dimensioning stuff like this, but there are other ways that we could do it. We could use a spline or something else, but this arc is going to be nice and consistent. We know that this point is 3 millimeters off the board. We know that this point is 3 millimeters over here. So we don't have to worry about the center. It's going to be centered on our origin. Then I'm going to finish the sketch, and I'm going to extrude this as a surface. So I'm going to say extrude, and I'm going to pull it out. I'm going to make this go symmetric in both directions. And notice that I'm going past the extents of my housing. Now, one of the reasons that we're doing this is because we need to build the surface from here. There is another method. There is another way that we could do this. And I'm going to show both of them. So this one is extrude, but here is the problem that we get when we're going down this road. We can't fillet this corner because there is no thickness to it. We could create ruled surfaces off the edges, and then we could fillet the corners, or we could create a sketch to trim it. But when we do a sketch to trim something like this, it's not as robust as basing it off of something else. So for example, if we were to come in and we were to add an arc to a 2D projected sketch, the 2D projected sketch isn't accounting for the curvature of this face, which means that as we adjust things, as we pull them around in 3D, then the curve where it's intersecting these two edges has the ability to change. So what we're going to do in this case, instead of the extrude, is we're going to fillet the solid body reference that we created. Then we're going to use our sketch to trim it. So we're going to get rid of this extrude. I'm going to just say delete, but we are going to keep this sketch. The sketch is going to help us define it. But then we're going to go to our solid tools and fillet, or F on the keyboard, and we want to fillet all these corners. Keep in mind that none of this has draft on it. So we're not worried about draft here, but we're just worried about the shape. In order to get the shape right, let's go to the top view and let's just take a look at how it is relative to our design. Remember, we're designing the inside face. So as long as we don't go over this corner here, it should be fine. So if you want to make it a little bit smoother, maybe more, more like an iPhone or something that just has very rounded shapes, then you can go ahead and increase it. I'm going to stick with 8 millimeters and we'll build from there. Next, I'm going to use split body. So with split body, bodies to split is that base, and the splitting tool is that sketch we created. We're going to say okay, and now we have two bodies in here. We've got this big base and we got this little piece. Either are going to be fine, but I'm going to hide body 10. I'm going to hide my sketch, and I'm actually going to hide the PCBs as well. Let's go ahead and get rid of all those, and let's hide this one as well. So now what I have is that arced face. It's only arced in one direction because we did it from the front here. It's only arced in that direction, but now it has the fillets on the side. So what we can do in surfaces is we can go to create and offset it 0 millimeters. We'll say okay. And now we've got a surface body that has that curvature in one direction. So here is the other thing that we need to be mindful of. What if we wanted that curvature in two directions? We couldn't use split body because that's going normal to the selected curve. So what would we do in a case where it needs to be curved in two directions? Well, let's back up a little bit again, and I'm going to delete these. And you're probably getting tired of deleting our work, but it is important that we go through the process and we understand each of these steps. So in order to get this to curve in both directions and meet these edges that we already defined as the lowest point for the inside that we want, I'm going to create another sketch. But remember, our origin and our coordinate system is based at the center of this design. And this is where it's helpful to have gone through those steps to make that work. So now I'm going to sketch here. I'm going to use P on the keyboard. I can project these edges, which is going to give me that line, or I could use an intersection. That would work as well. And then what we're going to do is now we've got these points. We also want to intersect this. So we can't project this because we want the point where it crosses our sketch plane. So we need to go to project include and intersect. And this is going to take our sketch plane and it's going to give us a point wherever it intersects that curve. We're going to say okay. And now we can use an arc. And in this case, 3-point arc. And we're going to drag it down until it snaps to that point. So now that arc is fully defined. So here, in the case of creating a surface that fits here, we have to create something that can use both of those as a reference. Now this is where it gets a little tricky because different software has different options. And the way that we do this in Fusion 360 is we're going to create a sweep. We're going to sweep this edge. We're going to do a single path, and the path is going to be this one. So this is going to give us that sort of bowl shape. All right, one thing you'll notice with this bowl shape is it doesn't intersect these corners anymore. And that's because what we're doing is we're taking this arc that we have here and we're pulling it up to this corner. So if we wanted to actually fit this shape, we need to get extremely creative. But again, we're not tied down to any specific design. We're not really concerned with actually matching a perfect shape of something that exists. We have some creative freedom here. So what we're going to do is we're going to say, okay, and then we're going to take the surface that we just created and we're going to offset it. So we're going to go to the side and we're going to pay close attention to offsetting this until it crosses these corners. So as we rotate around, you can see it hasn't completely crossed yet. We're going to pull it down a little bit more. You can see there our surface is now completely underneath at 1.5 millimeters. So I'm going to say okay. I'm going to hide the original, and then I'm going to use this new one to split my body. So we're going to go to our modify. We can go to split body. Bodies to split is again this one, and the tool is going to be our surface. It doesn't need to be extended because it already goes to the extent of the surface, but if we do that, it'll just push it out a little bit further. We'll say okay. And once again, we now have sort of broken this body up. This gives us a nice clean face that we can offset. And again, 0 millimeters. So now we have a face that is curved in 2 directions. So if we look at it from the front, it's curved this way. If we look at it from the left or right, it's curved that way. And we have these rounded corners. So doing it this way, it takes a few extra steps, but it gives us the basis to our design. We want to have good, clean surfaces. And doing it this way, creating that sweep and using those curves in 2 directions off of the solid body that we were able to fill at the corners, this is going to give us a nice, clean design. We have a single arc in this corner. We have a line, arc, line, arc. Well, these are all arcs or polylines, but this gives us a nice, clean surface starting point. So let's go back to a home view. And I'm going to rename this body. I'm going to call this base start. The rest of the stuff I don't really need. I could keep some of it if I want. So for example, if I needed to keep this face to use as a sketch plane for the start of a boss, then I can certainly do that. The bottom part isn't really that important, and these other surfaces aren't really that important, at least at this stage. So if I want to get rid of them, what I can do is I can right-click and remove them. So I'm going to get rid of the original concept because I don't need it. I am going to get rid of these 2 as well as the bottom piece, right-click and select remove. When we do that, it's going to place these in the timeline. I'm going to shift select all of them, right-click and create a group. I'm going to right-click and rename. And I'm going to call this base remove. And the reason I'm going to do that is because now if I hover over it, I can see the name of it, base remove, and I can see all the things that were removed. Notice that the names of the bodies that are removed, body 16, 15, 14, concept 1 and 2, having those originals named something helps us when we're trying to identify the removal. The bodies 14, 15, 16 don't tell me much, but concept 1 and 2 help me understand what we did. So now we have this curved base, we have our PCB, we have the microcontroller, and this is going to be the starting point for our design. We've got a nice clean surface, that's going to be our starting point, and now we need to build the shape around the rest of it. Now, you're probably already starting to realize that there are a lot of decisions that we make along the way, and every decision is going to have a consequence, either a pro or a con, something that we're going to have to deal with downstream. So we spent a lot of time exploring a couple different methods of creating the base or the bottom shape that we want to use for our housing. And the reason we did that is because we need to understand those design decisions. We could have very easily started with a flat plate and we just used an extrude that was our wall thickness and built up from there. That would have been an easy option. And if we were 3D printing, that's the way that I would go. I would want a nice flat base to help me 3D print it. But if we're trying to make something that has a little bit more appeal, has a little bit more shape, then we're going to have to go through this process of understanding the differences between just extruding a curve and splitting a body versus trimming a surface versus using a face off of a solid body or creating something like a sweep with curvature in 2 directions. They all have different implications, different uses, different reasons why you would want to do it. But this bottom face is going to give us strength in our plastic housing Because we ended up offsetting it 1.5 millimeters, that means when we thicken it, this could be the outside or the inside of our design. It really doesn't matter at this point. Because we have so much space here, it could simply just be the outside and we thicken it toward the design. We won't know for a little bit. We can always go back and change things like the sketch that we used or the offset surface that we used to determine where that was located. So all of these can be different design points or different design changes. What is important is that we remember that anytime we have something that's critical that we might need to go back to, that we should label that sketch or feature or group in the timeline. Sketch 6 and Sketch 7, I'm going to go ahead and rename side base curve, and I'm going to call this one front base curve. I double clicked on it so it went into edit mode. I'll call this one front base curve. So now if I'm ever looking back through and I come across the sketch in the timeline or I come across it in the browser, I know exactly what it is. And I don't have to be wondering what Sketch 1, Sketch 2, Body 1, Body 2 was. So this Body 10, I'm going to rename. I'm going to call this one Base Remainder. As you do this work more and more, you're going to come up with some nomenclature that makes sense to you, whether it's using the same terms over and over again. And a lot of times, I'll be completely honest, I will forget or sometimes just skip the naming stage. If I'm the only person that is going to see or work on a file, it's not as important to me to rename those because I can go back and I can look at the design and remember the steps I took to get there. But if you're working on a project with other users, if you're sharing your designs, if somebody else is going to have to do some step in the process, then taking the time to do this is important. There are a couple of more critical steps that we need. And the first thing that I'm going to do is I'm going to show you how to divide up the base that we created. Even though we've got this nice clean surface, we are working with symmetry. We know that our origin is based in the middle of this design because we created our sketches directly on the YZ and the XZ planes. So we're going to use that to our advantage, and we're going to model this in quadrants. And this is generally the process you take, noting that our design internally is not symmetric, but sometimes you make designs symmetric even though you've got wasted space on the inside. For purposes of downstream functionality, I'm going to go to Modify, Split Face, not Split Body, and I'm going to select this. Splitting tool is going to be my plane, in this case YZ. I'm going to say OK. I'm going to repeat that, select both of those faces, and now I'm going to split it this way, say OK. And the reason that we're doing this is because as we begin to build out the rest of this design, now we've got reference edges for curvature. We've got reference vertices for snapping geometry to. And each of these quadrants is identical. If we just drew one and we mirrored it across the XZ plane or we mirrored it across the YZ plane, then it'll perfectly match. And that's how we want to build. We want to build with the least amount possible because then it lets us control the curvature at those mirrors because we know that we're going to need tangency going across or curvature, which means that we can build out control surfaces and help us control that. But since this is a pretty big topic, I think this is a great place for us to start. So I'm going to save my design. And obviously, if you have any questions, please let me know, comment below, or send me an email. And as always, thanks for watching, and we'll see you in the next one.